Hi guys, this is our first official lesson for chapter 5. Just like on our first video, make sure that you're taking notes on everything. And you will want graph paper, so if you need to pause the video and go print out that graph paper, go ahead and do that now. In our first section of chapter 5, we're learning about the concept of rate of change, otherwise known as slope. We are going to define slope as the rate of change of a line. And so if I say rate of change, I am talking about slope. It's just a different way of saying it. In this first video, we're going to talk about finding the slope or the rate of change given a line graphed on a coordinate plane. So again, you want to make sure that you're copying this down into your notes and that you're accurately copying it into your notes. So you want to be doing this on graph paper. And you don't want to just be drawing any old random line. You want to make sure that your line and my line are a perfect match for each other. When we're finding the slope of a graphed line, what we're looking for is we're looking for the steepness of the line. How slanted is it? How much does it change as you're walking up or down the line? So that's what we're doing when we're finding slope. The slope of a line is describing what the line looks like. It's a descriptive word. It's an adjective. It is not the actual line. You cannot say, hey, look at this slope. Slope is not a thing. It's not a noun. It's an adjective. It's describing how the line looks. So make sure that when you're talking about the line, you say, hey, look at this line. It has a slope of this, okay? When we're determining the slope of a line, we're going to write a fraction. And the letter that we use for slope is the letter M. That's this letter right here. And for our fraction, on the top of the fraction, we're going to write down how much the line is rising. And for the bottom of the fraction, we're going to write down how much is the line running. So rise over run. This can get a little bit confusing when we think about an ordered pair, because in an ordered pair, we do the run first, the x first, and we do the rise second, the y second. So the x goes left and right, and the y goes up and down. But on a slope of a line, we're actually going to do the rise first. That's my y. That's how far up and down it goes. And we're going to do the run second. That's my x, and that's how far left and right it goes. So it's kind of the opposite of what we were doing in our first video with our ordered pairs. So you want to be very aware of which one are you doing. Are you doing an ordered pair? Or are you doing slope? Okay, and it switches which one gets done first and which one gets done second. To find the slope of a line, first you need to have 2 points on the line, 2 dots. You want those dots to be on nice whole numbers. So you want to find points on the line where the line is crossing one of these intersections, because that'll give us a whole number for the x and for the y. You don't want to pick a dot that's like halfway between. And you definitely don't want to pick a dot that's in the white space. So you want to, again, pick a dot that's on the crosshairs of those x and y numbers. It doesn't matter where the dots are. You actually, in this picture, I can see at least 3 different places where I could put a dot. And so we only need 2, so you can pick whichever 2 you want. But there are 3 different places. So I've put all 3 of them on here, and then you just need to pick 2 of them. And again, it doesn't matter which 2, but you need to know, that there can be more than 2. Next, you'll need to pick which of these dots you want to start at. Now, I always like to start at the leftmost dot. It makes it easier for me counting-wise if I start at the left dot. So I'm going to start at the left dot. And from the left dot, you're going to either rise up or rise down to get to your next dot. So if I'm starting at the left dot and I'm going to the right, my right dot is below my left dot, and so I will be rising down. Okay. So from my left dot, I rise down until I'm level with my next dot. From there, you're going to run. Now, if you always choose to start with your left dot, you can rise up or you can rise down, but you will always run to the right. And so that's one of the reasons why I like to pick my left dot, is because I like to always run to the right. When you're done doing this, you've created a right triangle with your line. So we have straight up and down and straight to the left or right, and then the line creates the hypotenuse of your right triangle. Next, we need to count our rise and our run. When you're counting how many boxes you went when you rose and when you ran. Okay, so again, if I'm starting up here at the left dot, I'm going to rise down, so negative, and I went down 1, 2, 3 boxes. And so my rise is -3 because I was going down 3 boxes. From my point, I went down 3. And now I am here. And so next I'm gonna count my run. And again, we're counting boxes. How many boxes over did you go? And so if I'm starting from here, I'm gonna count to the right, 1, 2 boxes. And so when you count to the right, it's positive. And so +2 is my run. And so my final answer for this problem, my slope of this line is -3 over +2, or just -3 over 2. Notice that I put the negative sign with the top number. It is best if you have a negative to actually attach it to one of the numbers. Don't just let it float in front of the fraction bar, because then it might get lost and it might kind of blend in with your fraction bar. Okay, so we're picking 2 dots. We're counting our rise first and our run second. Our final answer is always a fraction. For our next lines, I'd like you to try them on your own. So see if you can figure out the slope of these 2 lines on your own. Go ahead and pause the video and write down your slopes, and then we'll check in. All right. So first thing I want to point out is that these 2 lines have very different slopes. The green line, it starts up high and then it falls downward. And so when your line is falling downward, that's going to have a negative slope. So the green line, I can already tell you, is going to have a negative slope because looking at it from left to right, it's going downward. Now my red line starts at the bottom and then it rises up. And so when you see a line that rises up, that is going to have a positive slope. And so my green line should have a negative slope. My red line should have a positive slope, just from the general look of the lines. But let's check and see what those actual numbers are. So for my green line, I got a slope of -2 over 1. Notice that I still wrote it as a fraction, even though it could simplify to a whole number, because I want to know what is my rise and what is my run. So I need those 2 numbers. So if we start here and here, we can go down 2 and right 1. So that would be -2 over 1. We could also go up 2 and left 1. That would give us 2 over -1, which is pretty much the same thing. Okay, so that's my green line. For my red line, again, I'm expecting a positive slope for this one because it is rising up. And so I got a positive 1 over 4. So for my red line, we could start here and go to here. And so I'm going to rise 1 and run to the right 4. That's +1 over +4. Hey, if you go in the opposite direction, if you start here, you could rise -1 by going down 1, and then you would run -4 since you're going to the left 4. And a double negative turns into a positive. So you would want to simplify that a little bit and make it a +1 over +4. So when you're finding the slope of your lines, if you can simplify your fraction, you should. You do still want to write it as a fraction, so even if it simplifies to a whole number, still write it as a fraction so that we get that concept of rise over run. But don't, if you can simplify, do simplify. Okay, don't leave it with the big numbers, and don't leave a double negative. This concludes finding the slope of a graphed line. Over the next 2 days, we'll find the slope of different things, but that's it for today.